Welcome to another video. Today's segment is brought to you by the Magic Box. Check this out. Put the ball in, say the magic word, and voila. Make it appear. There, the Magic Box. So for today's video, we're doing rigid motion transformation, the worksheet, part 1. You all have that. So for the first week, we worked on transformations, but we did a visual one. This time, we're going to do exact same worksheet with hopefully you get all the answers and transformations correct. This time, we're going to do coding. And for coding, we're not going to use any patty papers or mirrors or anything like that. We're just going to do straight the paper rules. So example 1, we're going to go back to it. I'm going to give you only 2 examples for this one, okay? I'm going to probably do 1 and 3. So example 1, you're looking at a point and you need to find out the location of that. So coordinate x comma y. I even put it right here in the top, x and y. So my x value is 2, my y value is 1. So the coordinate of A is 2 comma 1. And now here's a little cheat sheet. If it's translation, you're asked to do this: 1 unit left and 2 units up. So here's how you would write it. X minus 1, it means left or right. Okay, so minus goes to the left, plus goes to the right. Up or down is the y. So if you want to increase the value of y or decrease the value of y. So in our case, here's how you write it down. So A is 2 comma 1. I'm going to rewrite it. And you're going to go to A prime, and A prime is going to have a new coordinate. So x minus 1, which in this case we're going to do 2 minus 1, comma, and y plus 2. Okay, our y was 1, so it's going to be 1 plus 2. And so let's go ahead, write down right below it. A prime is 2 minus 1 is 1, comma, 1 plus 2 is 3. And that's your answer, 1 comma 3. Let's go and check how it's going to look on our plane. So again, A prime is going to be 1 comma 3. So I'm going to go 1 and 3 up. 1, 2, 3. So this is where my A prime is going to be. And hopefully it matches what we did last week. Okay, again, 1 unit left and 2 units up. We did the exact same thing, but use the code. Example 3. Example 3 goes something like this. We got a whole shape to be shifted to a new location. Again, this is how our answer should look like. If you're doing coding, that's what you need. You can plug in that point later on. So in our case, you're looking at translation from x comma y to x plus 2 comma y minus 6. Now, we know the rule that we need to add 2 units to the x value and subtract 6 from the y. And let's go ahead and get the points in. So we got 3 points here. It's going to be I and H and J. And I'm sorry, I'm not going in a alphabetical order. I'm just kind of going from top to bottom. So my coordinate for I is, again, we need to count right here. Where's I? I is this way. So again, this is 1, this is 2, this is 3, this is 1, 2, 3, 4, and 5. So I is 2 on the x-axis, and the value of I on the y is 5. So the coordinate is 2 comma 5. H is going to be 3 comma 3. And J is 1 comma 1. So those are the coordinates of this of these 3 vertices. Now what we're going to do is we're going to perform what this says here. Again, this is our line of x's, these are y's. So this is going to turn into 2. The value of x was 2 plus 2. So treat it as this is our x, this is our x, okay? This is the value, 2 plus 2. Then comma, instead of y, I'm going to write down this 5 right here. So it's going to be 5 minus 6. Same thing applies to all of this. So instead of x here, I'm going to put down 3 plus 2, comma, 3 minus 6, because that's the y value. And finally, 1 comma 1, so I can even write down like this. Here's how I'm going to pre-write. Plus 2 and minus 6, and all I got to do is fill in this one. Okay, and so what that's going to get us is, that's going to give us is this. So put an arrow here, and we dealt with, oops, not this one, got here. I prime, this is our h prime, and finally this is our j prime. And we are going to put new coordinates here now. This is just simple addition. 2 plus 2 is 4, comma, 5 minus 6 is negative 1. 3 plus 2 here for h prime is 5, and 3 minus 6 is negative 3. And finally, 1 plus 2 is 3. And y minus 6, this is a tough one. Think about it as you have $1 and you overspend $6. So your balance now is negative 5. And that's your answer. Next in line is reflections, and example 17 will be our main focus here. So example 17 says reflection across the x-axis. Now, I don't know the rule for it, but I have included a cheat sheet. So we need to look for reflections, and then what do we need to reflect over? And you can choose any of those 4. And in our curriculum, we're not really going to do this too. So these are optional. So we're going to focus on either over x-axis or over y-axis. Those are the only 2 you need to know. In our case, our rule is from xy over x-axis, you're going to x comma negative y. This is going to be very simple, and anybody can do that. So I rewrote it right here in my little cheat sheet. So I already got the see again across x-axis. I already wrote the vertices here, so we just need to come up with the coordinates for those vertices. And let's go ahead and figure out what t is. So t is, again, negative 1, negative 2, negative 3, negative 4. So on the x-axis, t is at negative 3. And then you go, how many units you go up? 1, 2, 3. You go up 3, so it's going to be negative 3 comma positive 3. That's the t. So we're going to do the same process for all of these. For u, for example, u is 1, 2. So u is 2 comma 3, 2 comma 3, and s is negative 2 comma 1 unit up. It's negative 2 and 1. And finally, v is negative 1 and positive 1. Okay, so this is going to be our 1, this is going to be 2, this is going to be 3, 4, and so forth. All right, so now that we've gotten the x and y squared away, we don't really need this picture anymore. We're done. We're just going to go straight for coding. And this is the rule. X comma y, for reflection across the x-axis, it turns into x comma negative y. So all we got to do is keep x's the same. Okay, so we're going to keep x the same. And then switch the sign of y. That's it. So if x was negative 3, it's going to stay as negative 3. Now, and in here it says y is turning into a negative y, so we're going to write down negative 3. Because this was positive, now it turns into negative. Again, we're going to do the same thing process for all of this, so I know that x's are not going to be changed at all. So I can simply rewrite this is to be 2 comma, again, 3 was positive. What's the opposite of 3? Negative 3. Next, s was a negative 2, and it was positive 1, so it turns into a negative 1. And lastly, this stays the same, negative 1, comma, negative 1. And that's it. We've done a perfectly fine transformation. Now, next example, we're going to do rotations, and we're going to do question 26. It says rotation 90 degrees counterclockwise about the origin. So I'm going to go get my transformation cheat sheet, scroll down to rotations, and then find my rule. It says I need counterclockwise 90 degrees, and that's going to be my rule. So I already took liberty of writing it out here on my little cheat sheet, and I even copied the coordinates. The one that the interesting one is the x one, because it says 0 comma negative 1, because you went straight down. No movement on the x-axis, so 0 comma 1 unit down, so it's negative 1. Now let's apply the rule here. If it's the rule was xy moves to negative y comma x. Well, that's interesting, because now x is 2, and guess what? Now this 2 has to be the last number right here, and this y right here is now becoming the first number with a negative sign, with the opposite sign. This is going to be quite interesting, so let's pay close attention here. It says x is 2, so I'm going to write down 2 where x is, okay, because x is the last number. And y is going to be now the first number, but it has to be the opposite sign according to the rule. So now if y was 3, now y is turning into a negative 3. Let's do that one more time. X in this case is 4, so I know that my x has to be the last one, so it's going to be 4 right here, and my y is now in the front with the opposite sign, so it's negative 2. Last one, I'm going to pause here. So you can pause it too. You can pause the video and try to predict what number is going to be right in here. Well, x is 0, so x is on the last in the last spot, so it's 0. And now my y was negative 1, needs to be in the front. So now negative 1 is turning into positive 1. So I'm just going to write down 1. Why? I'm going to put it in red, because negative 1 is simply just positive 1. Two negatives make a positive. And that's your answer.